Hi, I'm Dr. Kathy Gorry.
And I'm Dr. Christine McGrath, and we're from the Faculty of Science at UTS.
Today we're going to talk about some of the key concepts of homeostasis. So Chris, if I asked you for a function of the kidney, what would you say?
That's easy, Kathy. Homeostasis.
Right, and what about the liver?
Homeostasis.
And if I asked you for a function of the skin?
I'd say homeostasis too.
Okay, that's not really a complete answer. What do you mean by homeostasis of the skin?
So the skin essentially regulates the temperature of our body.
Okay, so you're saying that homeostasis is about regulating stuff. That's the key concept. Let's have a look at homeostasis in a little more detail.
Here's a list showing 10 examples of different body systems that are regulated all the time. The body tries to keep all of these processes in balance, and a healthy body will maintain the correct levels and adapt when they go out of balance. So this is the way homeostasis works. Normally, the system is in balance. But when something happens, a stimulus that knocks it out of balance. A receptor will recognize the change and send input to the control center, which is usually located in the brain. An output message will then be sent back to an effector at the site of change, and a response will occur. So the body allows for normal fluctuations in a system. Each system is constantly regulated by stimuli and effectors to keep the response within a normal variable range. So the definition could be this: homeostasis is the body's ability to detect change, activate mechanisms that oppose it, and thereby maintain relatively stable internal conditions. Body systems can be regulated by both positive and negative feedback loops, although most examples are negative.
So here's a classic example of a negative feedback loop, the homeostasis of body temperature. Here, a stimulus could be a hot day. Your body temperature will rise, and the change will be noticed by the receptors in your skin. Information will be sent to the brain and back to the effectors, which in this case will be the sweat glands. You'll sweat, the sweat will evaporate, and that will cool you, and it will bring your temperature back into the normal range. It works the other way too. If you get too cold, a message will be sent to your brain and back to the effector, in this case the skeletal muscles, which will make you start shivering, and that will warm you up, and your temperature will come back into the normal range and be in balance.
But there are a few positive feedback loops as well. So in this example here, the stimulus is the baby. When the baby is ready to be born, the muscles around the uterus start to contract. So this put the system out of balance, but in this case, this is necessary. And this essentially causes a positive feedback loop. So then sends a signal to the brain to increase the contraction, and this put the system further out of balance. So this will continue until the baby is born, or until the stimulus is no longer present.
Here are a few examples of what can happen when homeostasis goes wrong. For example, homeostasis maintains body temperature within a particular range, but when it's too hot or too cold, the body can't work properly. You've probably learned about lots of different examples of homeostasis during the course of your studies. Make sure that you understand them. Think about what normal homeostasis is and what happens when homeostasis goes wrong. Think about some of the disease processes that can happen when homeostasis is disrupted.
I can give you one: diabetes. Diabetes is essentially a condition that results in the dysregulation of our blood glucose levels. So thank you for listening, and we hope this reminds you about homeostasis and how it works in our body.